Hi, I told you guys I would tape a video on the worksheet that was handed out on Monday and using kind of the rules that we found out for factoring. And let's just review those rules. I always look at the third sign. If I have a trinomial, I'm looking at the third sign or looking at the third term. Looking at third term. If the third term is positive, look at second term. And if it is positive, then my two are positive. If that second term is negative, then my two are negative. And then for a trinomial, if I look at the third term and it's negative, then automatically it's a positive and a negative. And I'll put third is a negative. So that's kind of just a little cheat sheet. And that's from our notes that we handed out, rules for factoring, on Monday. So going through this one, I am looking and my third term is a positive. So I know that I need to look at my second term, and that tells me that both binomials are both binomials are negatives. So then I look at 30 and I ask, what are my factors of 30? I have 1 times 30, 10 times 3, 15 times 2, and 5 times 6. And I know both of these factors are going to be negative, so which of these can I combine together, both negative, and my answer be negative 13? And the only ones are 10 and 3. So my answer is m minus 10 times m minus 3. The next one over here, I see that my third term is negative, therefore I know that one of my binomials is positive and one is negative. Then I ask myself, what are my factors of 56? 1 times 56, 2 times 28, 4 times 16, or 4 times 14, excuse me, and then 7 times 8. And I know I'm going to have to add one of these, or I have a positive factor and then I have a negative factor, so I have to see which ones I can subtract and come up with negative 1. So, and the only two factors are 7 and 8, and so I know that that has to be negative 1, so I know my 8 is going to be negative and my 7 is going to be positive. Number 3, looking ahead, I know that I'm going to have two binomials. I have a positive as my third term and then a positive as my second term, so both of my signs are going to be positive. Then I'm going to 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10. And I know adding 10 and 10 together is going to give me 20a. So in this case, it's a plus 10 times a plus 10. Next one, I have two binomials. They're going to be multiplied together. I have a positive as my third term and a positive as my second term. So I know that they're both going to be positives, or both going to be plus signs. So then I start listing my factors of 12, my third term, 2 times 6 and 3 times 4. And I have to figure out which ones can I add together and it equals 7. And the only ones are 3 and 4. Number 5. Number 5 looks a little different because I'm actually solving for what n equals. And this is an equation versus the expressions up in 1 through 4. But I've set up my binomials the same way. I look at my third term, it's negative, so I know one's a negative, one's positive. Think of what my factors of 7 are, and they're 1 and 7, and that's the only one. So how can I put these in so where it equals 6? And so if I have a positive 7 and a negative 1, it's going to equal 6. So then I set each of my binomials equal to 0, and I have n is equal to 1, and n is equal to negative 7 by adding 1 to both sides, by subtracting 7 from both sides. Number 6, I see that it is a perfect square. So, or the difference of perfect squares. So 1 is going to be negative, 1's going to be positive. I take the square root of 25b squared, and that's 5b. 5b, and the square root of 9 is 3. And so then I set both of these equal to 0. and 5b plus 3 is equal to 0. And whenever I solve it, my b is going to equal plus or minus 3/5. Moving on to number 7, it's going to be the difference of perfect squares again. So I know I'm going to have a positive, and I know I'm going to have a negative, and I take the square root, and that's 3b, square root of 9b squared, and the square root of 25 is 5. So then I set each one equal to 0 to solve for what my values would be. 3v minus 5 is equal to 0, and so v is going to be equal to plus or minus 5/3 whenever I solve those. Number 8, I see they are the difference of perfect squares again, so I have a plus and I have a minus, and the square root of x squared is x, and the square root of 16 is 4. I set both of these equal to 0 and solve for x is equal to plus or minus 4. Same thing from 9, it's the difference of perfect squares, and 2n minus 2n plus minus 1 plus 1, solve. Minus 1 is equal to 0, 2n plus 1 is equal to 0, so n is going to equal positive or negative 1/2. Number 10, 11, and 12 are a little bit different. They all have a common GCF. And in this case, the GCF of both terms is x. So when I factor out an x, I'm left with 4x minus 7 equal to 0. And again, I set both of them equal to 0. And I solve, so x is going to equal to 0, or x is going to equal to positive 7/4. Number 11 is the same way. I can factor out a k, and so I'm left with 7k plus 3 equals 0, so k is going to equal to 0, and then 7k plus 3 is going to be equal to 0, and k is going to equal to 3/7. Number 12, I have the same thing. I can factor out an r, and so I have r is equal to 0, and then I have 3r plus 4 is equal to 0, so r can be 4/3, or r can be 0. So hopefully that helps you, and you can kind of follow the rules and study for your test that will be Friday.